Since the dawn of civilization, poison has been the weapon of choice for those who didn't want to get their hands dirty. Silent, invisible, and often impossible to trace, it has crossed empires, taken down kings, and reshaped entire wars. But what actually happens inside your body when a poison enters? Today, we're going from the least lethal to the most destructive substances ever created by nature and science. And here's a spoiler. The last one can kill with an amount you wouldn't even be able to see. Bee venom. Let's start with something most people have experienced in real life. Bee venom, known as apoptoxin, is a complex mix of proteins, enzymes, and peptides. Its main component is melatonin, making up about 50% of the dry venom. When it enters the skin, melatonin pierces cell membranes, causing that sharp pain and swelling. For most people, a sting is uncomfortable but harmless. The real danger begins when the immune system overreacts. In people with severe allergies, the body releases a massive amount of histamine within seconds. Blood vessels expand, blood pressure drops, and the airways begin to swell. This is anaphylaxis, and without epinephrine, it can kill in less than 15 minutes. It's not the venom that kills you, it's your own body going into panic mode. The estimated lethal dose for a healthy adult is around 1,000 to 1,500 stings at once. Possible but extremely unlikely in everyday life. Next is Atropa belladonna, commonly known as belladonna, a European plant with a long and dark history. The name belladonna means beautiful lady in Italian and comes from the habit of Renaissance women dripping its extract into their eyes to dilate the pupils, which was considered attractive at the time. The problem is that the compound responsible for this atropine is a potent poison. Atropine blocks the acetylcholine receptors in the nervous system. This sounds technical, but the practical effect is brutal. The body loses control of autonomous functions, the mouth dries out completely, vision becomes blurred, the heart speeds up in an uncontrolled way, body temperature rises, hallucinations begin. Many victims report seeing insects covering the skin or feeling like they are flying. In high doses, the heart simply cannot keep the rhythm and stops. Just a few berries are enough to kill a child. For adults, the lethal dose is around 10 to 20 berries. During the Middle Ages, deadly nightshade was used in political poisons, often enough that doctors of the time described its symptoms in precise detail, which says a lot about how common it was to encounter this kind of death in European courts. Now, cyanide has one of the densest histories among the poisons on the list, used in executions, mass suicides, political assassinations, and chemical warfare. It is at the same time simple in composition and devastating in its effects. Potassium cyanide or sodium cyanide works by blocking an enzyme called cytochrome C oxidase, which is essential for cellular respiration. In simple terms, your cells stop being able to use oxygen even though there is enough oxygen present in the blood. It's like suffocating from the inside with the lungs working perfectly. The symptoms appear in seconds: intense headache, dizziness, mental confusion, seizures. In high doses, loss of consciousness happens in less than 1 minute. Death from cardiorespiratory arrest follows in a few minutes. The lethal dose for humans is approximately 1.5 milligrams per kilogram of body weight. For an adult of 70 kilograms, less than 110 milligrams are enough, an amount that fits in a small teaspoon. Cyanide was the poison used by Adolf Hitler and Eva Braun in their suicides in April 1945, and by the leader of the People's Temple, Jim Jones. In the Jonestown Massacre in 1978, where 909 people died after ingesting a contaminated drink. Now let's move on to the inland taipan snake venom. If there is a title for the most venomous snake in the world, the Australian inland taipan takes it without discussion. A single bite contains enough venom to kill more than 100 adult humans or 250,000 rats. For comparison, the American rattlesnake would need 10 bites to cause the same lethal effect. The taipan venom is a precise combination of neurotoxins, hemotoxins, and mucin. In other words, it attacks the nervous system, the blood, and the muscles simultaneously. The neurotoxins block the transmission of signals between nerves and muscles, causing progressive paralysis. The hemotoxins activate the blood clotting system in an uncontrolled way, making the blood clot inside the vessels at multiple points at the same time, a process called disseminated intravascular coagulation. the muscles begin to break down, releasing proteins into the bloodstream that clog the kidneys. Without an antidote, death occurs between 30 minutes and a few hours depending on the dose. With quick treatment, survival is possible, but the inland taipan is so aggressive and lives in such remote regions of Australia that fatal encounters still happen. Blue-ringed octopus venom. The blue-ringed octopus is one of the most disturbing examples in nature. It is no more than 20 centimeters long, it is visually beautiful and seems harmless, but it carries enough venom to kill 26 adults in minutes, and there is no antidote. The compound responsible is tetrodotoxin, produced by bacteria that live in the animal's body. It blocks the sodium channels in neurons, completely preventing the transmission of electrical signals through the nervous system. The result is a progressive paralysis that starts with the peripheral muscles and moves to the respiratory muscles. The victim remains completely conscious throughout the entire process. You feel everything, you hear everything, but you cannot move a single muscle, including the diaphragm. Death happens by asphyxiation while the mind is still active. The only possible treatment is manual mechanical ventilation until the venom is metabolized by the body, which can take hours. Tetrodotoxin is also found in the pufferfish, the famous fugu of Japanese cuisine. Chefs need years of training and a special license to prepare the fish, because the margin between the safe amount and the lethal dose is extremely small. Ricin in 1978. A Bulgarian dissident named Georgi Markov was waiting for a bus in London when he felt a prick on his thigh. A man had pressed a modified umbrella against his leg and injected a microcapsule of ricin into the tissue. 3 days later, Markov was dead. The case became known as the umbrella assassination and went down in history as one of the most sophisticated of the Cold War. Ricin is extracted from the castor bean, a common plant found in many parts of the world. The extraction process is relatively simple, which makes it one of the most concerning toxins from a global security perspective. Inside the body, ricin enters cells and blocks protein synthesis. Without new proteins being produced, the cells simply stop functioning and die. The process affects multiple organs simultaneously: liver, kidneys, spleen. Symptoms begin between 4 and 8 hours after exposure with nausea, vomiting, and intense abdominal pain. In the following days, the organs begin to fail in sequence. There is no approved antidote. Treatment is only supportive. Try to keep the body functioning while the poison acts. The estimated lethal dose is only 1 to 10 micrograms per kilogram of body weight. And we reach the top of the list: botulinum toxin. Produced by the bacterium Clostridium botulinum, is the most toxic substance known to science. A single gram, distributed efficiently, would theoretically be enough to kill more than 1 million people. To put it in perspective, the estimated lethal dose by inhalation is only 1.3 to 2.1 nanograms per kilogram of body weight. A nanogram is 1/1,000,000th of a milligram. The mechanism is elegantly destructive. The toxin blocks the release of acetylcholine at the neuromuscular junctions, the chemical compound that nerves use to order muscles to contract. Without that signal, muscles enter progressive flaccid paralysis. It starts in the face, eyelids drooping, difficulty swallowing, double vision. It advances through the neck, the arms, the torso, and finally, the respiratory muscles. Death without treatment occurs from respiratory failure. The mind remains completely lucid throughout the entire process. Just as with the blue-ringed octopus venom, natural botulism, caused by contaminated food, mainly homemade preserves, still kills people every year around the world. The most ironic thing of all is that this same toxin, in infinitesimal and purified doses, is the active ingredient in Botox injected into millions of people every year to treat wrinkles, migraine, and muscle spasms. The line between poison and medicine is always a matter of dose.